Learning objectives. At the end of this topic, you will be able to understand the need to measure degree of hotness or coldness of an object. Relate heat to temperature. Use a thermometer for the measurement of temperature. Compare different types of thermometers. Understand and explain heat in solids, conduction, liquids and gases, convection. Discuss about the seasonal clothes.
Ouch!
Hey, be careful! Hold it by the handle. The drink in the cup is burning hot.
Yeah, the cup feels hot but the handle doesn't. I can hold the cup easily by the handle. My chocolate drink is too hot. I can't drink it yet.
Let the drink cool first. You can have it later.
A moment later.
My drink isn't so hot now.
Why is the cup hot but the handle isn't? Why does the hot drink become colder after a while? Discuss this with your friends.
Heat is a form of energy. Heat can be transferred from one substance to another substance. This happens if one substance is hotter than the other or colder than the other. One substance will receive or gain heat and the other will lose heat. Now let's see what happens when a substance gains heat.
The sun is a source of heat energy. Our body gains heat from the sun. We feel warm under the sun. A pile of burning firewood produces heat. The human body gains heat from the fire. This is one way people keep themselves warm. Put both of your hands together. Rub your hands together for a minute. Put your hands on your face. Both of your hands will feel warm. The friction, which is the rubbing together of the hands, produces heat energy. We boil water in an electric kettle. The electrical energy changes into heat energy. The water gains heat. The water becomes hot. We may use a hammer to knock in an iron nail to build something. The knocking of the hammer on the nail produces heat and sound energy. The iron nail gains heat energy and becomes hot.
Raju is not feeling well. He is at the clinic. The doctor is checking Raju.
Please open your mouth. I need to take your temperature.
He has a fever. His body feels hot. That is why the doctor is taking Raju's body temperature. Measuring temperature tells us how hot or how cold something is. Look at what the doctor is using. What tool is the doctor using? Click on the tool to find out. It is a clinical thermometer. The clinical thermometer is used to measure body temperature. This is also a thermometer. It is a laboratory thermometer. The laboratory thermometer is made from a glass bulb that is connected to a long, thin glass tube. On the surface of the glass tube, there is a scale. From the scale, we read the temperature of how hot or cold something is. Let's look at the scale on the thermometer. What is the unit used for measuring temperature? What is the minimum value of the scale for this thermometer? What is the maximum value of the scale for this thermometer? Discuss these questions with your friends. Then click Check. The unit used for measuring temperature is degrees Celsius. Celsius is the metric unit for measuring temperature. Each line on the scale represents 1 degree Celsius. The minimum value on this thermometer is minus 10 degrees Celsius. This is how minus 10 degrees Celsius is written. The maximum value on this thermometer is 110 degrees Celsius. This is how 110 degrees Celsius is written. Now look inside the glass tube of the thermometer. There is a liquid inside the glass bulb and the glass tube. What liquid is it? The liquid is mercury. Sometimes the liquid may be a colored alcohol. This liquid will rise or fall depending on the temperature around the glass bulb. When the temperature rises, the liquid will rise. When the temperature falls, the liquid will fall. We can measure accurately how cold or how hot a substance is. We use a thermometer to measure the temperature of the substance. Now let's use the thermometer to measure the temperature of some water. Think of how you're going to do that. Then measure the temperature of the water.
I hold the thermometer at the thin end. We should not hold the glass bulb of the thermometer. Then I dip the thermometer into the water. I make sure that the thermometer is vertical. The thermometer should not be touching the side or the base of the beaker. To take a reading, I look straight at the thermometer. My eyes are at the same level as the top of the mercury in the glass tube. I can see the meniscus of the mercury. The meniscus is curved upwards. I take the reading on the meniscus. The temperature of the water in the beaker is 28 degrees Celsius.
Let's read the temperature on the thermometer. Can you read the temperature correctly? What is the reading on the thermometer? Key in your answer in the space provided. The mercury in the thermometer rises and stops here. The meniscus is in between 30 degrees Celsius and 40 degrees Celsius. Each line on the scale represents 1 degree Celsius. So, 30, 31, 32, 33, 34, 35, 36. The reading is 36 degrees Celsius.
Now, let's look at the thermometer again.
What is the reading on the thermometer? The mercury in the thermometer falls and stops here. The meniscus is in between 20 degrees Celsius and 30 degrees Celsius. Each line on the scale represents 1 degree Celsius. So, 20, 21, 22, 23, 24, 25, 26, 27. The reading is 27 degrees Celsius. This is how to read a thermometer correctly. Suji is carrying out an activity. She wants to measure the temperature of 250 ml of water while the water is being heated.
I record the temperature of the water before heating it. I light the burners to heat the water. I will observe and record the temperature every 2 minutes in a table. I will use a stopwatch.
Carry out your own activity too. Then let's see the observations of Suji's activity.
This is my record of the temperature of the water. Before I started heating the water, the temperature was 28 degrees Celsius. After 2 minutes, the temperature of the water was 35 degrees Celsius. After 4 minutes, the temperature of the water was 44 degrees Celsius. After 6 minutes, the temperature of the water was 52 degrees Celsius. After 8 minutes, the temperature of the water was 61 degrees Celsius. Now, I'm going to take the temperature of the water as it cools down. I will turn off the burner. I record the temperature of the water.
Carry out your own activity too. Then let's see the observations of Suji's activity.
After every 2 minutes, I take the temperature. This is my record of the temperature of the water as it cooled down. When I turned off the burner, the temperature was 61 degrees Celsius. After 2 minutes, the temperature was 57 degrees Celsius. After 4 minutes, the temperature was 54 degrees Celsius. After 6 minutes, the temperature was 51 degrees Celsius. After 8 minutes, the temperature was 48 degrees Celsius.
We observed and recorded the temperature of water as it was being heated. We observed and recorded the temperature of water. Now let's look at the tables. What conclusions can we make based on the observations? Discuss this with your friends. Transfer of heat. Let us understand the different modes of heat transfer in the object. Heat transfer takes place in 3 ways: conduction, convection, radiation. Click the tabs to know more. Let us discuss about the first form of heat transfer, conduction. Conduction takes place in solids. When the heat is transferred from the hotter end to the colder end of an object, it is known as conduction. The materials which allow heat to pass through them easily are conductors of heat. The materials which do not allow heat to pass through them easily are poor conductors of heat, such as plastic and wood. Poor conductors are known as insulators. Now let us conduct an experiment to depict the conduction of heat. Take a straight and flat iron rod. Fix certain nails using wax. And fix the rod onto the stand. Now heat the other end of the rod using spirit lamp. You will find the nails fall down one by one. The nail near the end of the lamp falls first, followed by the neighboring nails. The nail near the end of the rod facing the stand will fall last. This proves heat supplied by the spirit lamp flows to the other end of the rod by conduction. In solids, molecules are closely packed, touching one another. When the heat is supplied to the rod, the molecules absorb the heat and begin to vibrate vigorously. This vibration is passed on to the neighboring molecules, which allows the neighboring molecules also to vibrate. Hence, this vibration is transferred throughout the rod. Thus, in this way, the heat is transferred from the hot region to the cool region. Transmission of heat in solid substances takes place through conduction. In order to transfer the heat from the hot portion of the body to cold portion, the hot body should be in contact with the cold body. When the temperature of these two portions becomes equal, the conduction of the body stops. We can observe this phenomena using a thermometer. When the bulb of the thermometer touches the hot substance, the mercury absorbs the heat and it expands. When the temperature of the thermometer and the substance are equal, there is no conduction of heat taking place. Hence, the level of mercury does not increase further. Two conditions are to be fulfilled in order to transfer heat from one object to another object by conduction. 1. The two objects must be touching each other. 2. There should be some difference in temperature of the two objects. Heat transfers from the object at a higher temperature to the other, which is at a lower temperature. Let us discuss about the second form of heat transfer, convection. Convection takes place in liquids and gases. It is the transfer of heat through the movement of particles. In convection, warm particles rise and the cool particles fill in the space below. It is circular in motion. Let us do an experiment to depict the convection of water. The apparatus include a large round-bottom flask, potassium permanganate crystals, a tripod stand, spatula, lighter, and a burner. Fill the round-bottomed flask with water and place it over a tripod stand. Add potassium permanganate crystals with the help of spatula onto the water. Give some time for the potassium permanganate crystals to settle down. Place the burner below the tripod stand and burn it with the help of the lighter. Now let's wait and see what happens. When the water at the bottom of the flask is heated, it expands and the expanded water is less dense than the surrounding water and therefore starts to rise. In doing so, the cooler regions of water at the upper part of the flask, being denser, sinks. This movement of liquid due to the difference in density set up a convection, as you see in this video. Let us discuss about the third form of heat transfer, radiation. Radiation is the transfer of energy in the form of waves. Heat energy travels through matter or empty space. All hot bodies radiate heat. When this heat falls on some object, a part of it is reflected, a part is absorbed, and a part may be transmitted. The temperature of the object increases due to the absorbed part of the heat. Let us understand the transfer of heat by radiation from the video. During the day, the sun heats up both sea and land. But land heats up faster than sea and by evening heats up the air above it. This causes the air above the land to rise. This creates a low pressure of air above the ground and a high pressure air from the sea rushes in towards the land. So during the evening, air flows from the sea towards the land and it is called sea breeze. During night, land cools faster than the sea. So now sea heats up the air above it. This causes air from the sea to rise. This creates a low pressure of air above the sea, and a high pressure air from the land rushes in towards the sea. Season clothes. There are some clothes you can wear throughout the different seasons. In hot weather, white or light-colored clothes suit better because they reflect the heat and keep the body cool, whereas black clothes retain heat. During summer, clothes made of cotton are more comfortable. Cotton clothes allow the body heat to escape. Hence, summer wear should be breathable, light-colored, and loose-fitting rather than dark and tight-fitting. Winter clothes. In cold weather, warm and thick clothes should be worn. A wool-based layer helps maintain body temperature at a comfortable level in either cool or warm conditions. As wool is a very good insulator and a poor conductor of heat, woolen clothes keep the body warm and protect it from the cold winds. Also, the air trap between the woolen fibers prevents the flow of heat from the body to the cold surroundings. Thus, dark, thick woolen garments are suitable during winter. Summary. Let's summarize the topic. Temperature is a measure of the degree of hotness of an object. Thermometer is a device used for measuring temperatures. Clinical thermometer is used to measure our body temperature. The range of this thermometer is from 35 degrees Celsius to 42 degrees Celsius. For other purposes, we use the laboratory thermometers. The range of these thermometers is usually from -10 degrees Celsius to 110 degrees Celsius. The heat flows from a body at a higher temperature to a body at a lower temperature. There are 3 ways in which heat can flow from one object to another. These are conduction, convection, and radiation. The materials which allow heat to pass through them easily are conductors of heat. The materials which do not allow heat to pass through them easily are called insulators. Dark-colored objects absorb radiation better than light-colored objects. That is the reason we feel more comfortable in light-colored clothes in the summer. Woolen clothes keep us warm during winter. It is so because wool is a poor conductor of heat and it has air trapped in between the fibers. We have seen different types of thermometers. Different types of thermometers are used to measure temperatures of different things. Now let's carry out some activities to find out. The normal human body temperature. Room temperature. Freezing point of water. And the boiling point of water. Make sure you use the correct thermometer to find out the different temperatures. Find out the correct way of using the thermometers before you use them. Record your observations in a table. Share your observations with your friends.